Good morning, everybody. Thanks for your patience there. We just had to solve a couple of small technical problems. Welcome to the third day of our EASA Safety Week. My name's John Franklin and I'm Head of Safety Promotion here at EASA, and I'm just kind of supporting the logistics and the whole week this week. We've had a great bunch of discussions these past 2 days. 3 more webinars today, and for this first one we're going to be talking about CNS Resilience. So before we get started and really into the topic, I'm just going to cover a couple of the logistics. So just for those of you who haven't been in any of these sessions before, we've all been on those Zoom calls or WebExes or whatever where somebody forgets to mute their microphone and all of these things. So in this WebEx webinar format, we use all of the audio, all of those of you in the audience, your microphones are muted and automatically, and your cameras are off. So if you're trying to unmute, it's not possible. We have lots of great ways for you to interact with us though, so we would love your questions. So what we have is in the bottom right hand corner of your screen, you should have an apps box and then Slido, and you should see that come up in the bottom right hand corner. Within that, we then have a Q&A section where you can then ask questions within the Slido. You can upvote other people's questions, and then we'll try and get through as many later on in the session as we can. We'll save the ones we don't get to and then see how we can use those in our future safety promotion activities. We'll be recording the session, so we'll post that on the AirOps community site, and I'll email the link to everybody who's registered probably tomorrow or maybe Friday morning. I think that's pretty much most things. The other thing is, if you have any technical problems or you need to ask me any questions as the host, there's also a chat function. So if you use the chat function, if you have a problem, you can message me, and yeah, I can try and help you as much as I can. So hope that helps. Looking forward to a great session. Hopefully you'll enjoy it, and I'll hand over to my colleague Ivan Ferens from our ATM team, who's going to lead you through the session. Ivan.
Thank you, John. Welcome everybody. Let me to start. Resilience of system for communication, navigation and surveillance is typically ensured by their diversity. For instance, if one ILS failed, it is still possible to land in another runway or another airport. This might not be possible when we experience a failure of CNS systems that are provided on global or pan-European basis. But this is our future. According to the ATM master plan, the future CNS infrastructure will be based on integrated CNS that will include both pan-European and global elements. This integrated CNS will be complemented by minimum operational network. That's why it is important to talk about the CNS resilience now, and I appreciate that this topic has been included to the agenda of the Safety Week. It is my pleasure to welcome here 5 panelists of this session: Ignacio Ancatarina from European Commission, Benoit Roture from DSNA, Thomas Kleiman from DFS, Thierry Saleh from MUAC, and Steven van Hoveringen, a flight instructor and EASA consultant. The panelists will provide a brief presentation in their individual field of expertise, and then we will continue with the panel discussion on 4 pre-selected topics: a day without GPS, minimum operational network, CNS equipment on board, and common mode failures of integrated CNS. As mentioned by John, please use Slido tools to place your questions. We will respond to as many of them as we can, according to the popularity. So we use also this voting feature for that. So, and I'm Ivan Ferens, working for EASA as a senior expert in ATM ANS, and I will moderate this session. Currently, civil aviation in Europe use exclusively GPS L1 signal with aircraft-based, satellite-based or ground-based augmentation. Its reception might be influenced by various factors like geographical location, ionospheric or geomagnetic storms, electromagnetic interference, or jamming. What is planned to be done to improve the intrinsic GNSS resilience will be presented by our first panelist, Ignacio Alcantarilla, who is a European Commission policy officer working for EGNOS and Galileo in DG DEFIS. He worked for 12 years in the airspace industry and joined the Commission 10 years ago. He is currently also working on alternative position network and time services and the update of European radio navigation plan. Iñaki, the floor is yours, please.
Thank you, Ivan. Thank you for the invitation to join you in this very interesting webinar. I have a short presentation that I will be delivering to you just right now. I hope you can see the screen.
Yeah, works perfectly. Thanks, Ignacio.
Okay, so I will just briefly guide you through to this presentation, which is entitled Towards More Resilient GNSS. I will be saying some basic facts that probably you are much aware of, just to set up the context. You know, as Ivan mentioned, that civil aviation uses today exclusively GPS L1 signals with augmentation systems for more demanding applications like precision approach. Still, the dual frequency multi-constellation services are to come. But these signals from GNSS, they have lower power, and they can be then easily disrupted. We have the phenomenon of jamming, which is intentional interference and typically leads to a loss of availability. And we have also spoofing, which is faking the signals from the GNSS systems, and this could lead to a loss of integrity. These GNSS disruptions have been increasing over the last years, and we see it more and more often, typically in military and conflict areas. And we know that, unfortunately, to have more resilient GNSS service is not just going through one additional solution, but it's a multifaceted effort. So it will be many activities that will need to be required to enable a resilient GNSS services. So what are we working on to improve GNSS resilience? Basically, we are doing it through four main avenues. The first one is try to make the signals more resilient, and not only the signals, but the data. We will see that for this we have authentication and encryption. We also tend and will need to be using multi-constellation and multi-frequency GNSS signals. This is a clear recommendation from ICAO. We also have to better mitigate, detect, and localize the interference threats. Okay, this is typically a national prerogative, but it's also key in reducing the risks of disruption. And finally, we have to maintain alternative solutions. In aviation, you have your minimum operational network. It's well aware. In other domains, they are not so much aware. They need to keep something alternative to GNSS. So we are going to go in a little more detail in these four activities. In terms of in terms of more resilient GNSS signals and data, you are aware that today digital data is used everywhere and it is protected. You are, of course, aware that when you connect to your bank account through the internet, being the internet an untrusted environment and medium, you need to encrypt the data and in a way authenticate the connection between you and your bank. However, the GNSS signals that are used as much as you could use internet, they are not protected, and therefore they are easy to falsify. What we are trying to do is to improve those GNSS signals, including the authentication and encryption mechanisms that are today fully available in the telecommunication world. For Galileo, we are introducing new services, what we call OS NMA and CAS. We will go a little in detail in the next slides, and GPS3 is also intending to do something similar. And for SBAS, we are also pretending to introduce authentication. So what is OS NMA? OS NMA stands for Navigation Message Authentication, and this is a mechanism to authenticate the data of the navigation message. That is, the satellite orbits, the clocks, the times, and this will allow the receiver, the GNSS receiver, to verify that the data is authentic and that it is being transmitted indeed by Galileo system. It will not have any degradation on the PVT accuracy. You can see on the right two different plots with and without OS NMA, and the results are exactly the same. And this service, which is already available in the space, it will be declared formally next year in 2023. This functionality will also come in GPS-3 satellites. And this week, last week, it was presented in the ICAO navigation system panel. And the goal is to standardize this functionality for aviation together with standardization of SBAS authentication. And we will see a little later what's the timeline for that. So this is coming from the GNSS Galileo perspective. We have a second functionality that, unfortunately, I will jump to the conclusion, it's not planned for use in aviation, but which is to encrypt the signal. It's what we call a spreading code authentication. This gives an additional layer of protection to certain spoofing attacks. This is based in Galileo in the frequency band E6C, and therefore this band is not planned for use in aviation, and today there is no intention to use this in aviation. I wanted to pass the message that we have to and we can not only encrypt or authenticate the data, as we are going to do, and we are going to do it for aviation, but also the signal can be encrypted. So we see that from the GNSS systems perspective, so signals can be made more robust, more resilient by authenticating or encrypting them. But at receiver level, what we need to do is to use multi-constellation, multi-frequency. So what is the timeline to have standards and products in the market so that we can use these kind of solutions? In terms of SBAS, DFMC SBAS, so augmenting in Europe GPS and Galileo, and including on top this ARM or horizontal ARM, which will substitute the RAIM, we are talking about dates of applicability by the end of 2025. So by the end of 2025, we will have SARPs, we will have MOPs, including DFMC SBAS plus HRM, and therefore we could start using or start having those products. Important to know is that the DFMC SBAS service itself will come later in Europe. We are thinking about 2028. However, the HRM could still be used if we had a sufficient number of GPS and Galileo satellites. Okay, so this does not include the authentication capabilities, that it's coming in a second step. And we are doing work now for the validation, for the CONOPS, for a certain number of things. And you can see here that if we consider an additional 3 years period, we will have an applicability of about end 2027. So then we are working on standardizing the DFMC solutions. On a second step, the authentication of those DFMC SBAS solutions. And maybe important for you to know is that this will be optional for the service provider. So the service provider may decide to include authentication or not. It could be different in Europe, in the US, elsewhere. And it will be possible for L5, but also for L1, for the MOPs that will comply with this standard. Even in L1, you could have service providers providing authentication. And once this is provided by the service provider, if they choose to do so, then the receiver will need to process this information. So then authentication is very likely coming in DFMC SBAS and even in L1 SBAS by the end of the decade. Okay. So we have seen then measures to improve the signals of the GNSS themselves, measures to improve at receiver level how to make things more robust. Third avenue is to try to identify and assess RFI, so radio frequency interference threats, as quick and as better as possible. For that, we have launched already 1.5 years ago at DEFIS a project that we call IRING, that it's still running, that is assessing how we can, through several techniques, detect, mitigate, and localize these RFI threats. We are thinking and we are assessing on board, on ground, in a space elements. And we are doing that also, we are going to test it through laboratory and live demos. The purpose of this project, which targets to end by early next year, is to propose requirements that will go into the GNSS standards or monitoring means or reporting that will go to other type of documents. It's also working on a CONOPS to have mitigation actions and contingency plans for all the stakeholders so that we can mitigate the case of disruption of GNSS signals. And we are also going to select the most promising techniques to reduce the impact on the operations. As a hint or as a flavor of what's still being worked out, we have the preliminary conclusions of these CONOPS, which I would try to very quickly summarize. It's important that we have coordination procedures defined between the stakeholders, so in advance, and then these are implemented when the GNSS disruption takes place. ATC should handle these events operationally, even if they are unlikely or not so unlikely lately. The detection time is key to ensure that indeed this does not escalate into a major problem, especially if there is a spoofing, if there is misleading information from GNSS. We should, or aviation should, not use only GNSS for time stamping when using it for surveillance and communication. This is a very important recommendation, that GNSS should not be the common mode of failure of CNS. And then that, as you know, the operations based on GNSS, as it will be the case from 2030, according to the PBN IR, should keep a minimum operating network as contingency in case of contingency operations. Okay. Finally, just to let you know that on top of those, all these measures, we need to still keep an alternative PNT. This is the typical name we give for other sectors. On aviation, you call it a minimum operational network, but this needs to be maintained. In your case in aviation, you are, I would say, the best student in the class, in the sense that you are coming from conventional navigation aids infrastructure, and therefore you already have this alternative PNT infrastructure. What you need to do is to keep the minimum one, so that indeed, if there is a GNSS disruption, you can still maintain your operations. At our level, at DigiDefis, we are assessing not only for aviation, but for other domains, what are the technologies that could deliver PNT independently from GNSS. We launched several projects, even 7 projects. We have had a demonstration of those projects recently in JRC, and we have seen that there are technologies that can indeed provide either timing or positioning and navigation independently from GNSS. All this will be reflected in a summary way in the update of the European Navigation Plan that we intend to do at DigiDefis by the end of this year. Important to mention is that for aviation, none of these technologies will solve the problem in the coming years, because these are pretty new technologies and with a level of maturity which is not probably suited for your regulated application. So you will still need to continue working on what you have been working so far, DME or any other activities or alternatives that you know. So there is no, in our opinion, a magic new technology that will solve the possibility when GNSS will be disrupted. And this is what I wanted to mention. There is a couple of more slides that you will get with the presentation, and you have more information there. Thank you very much.
Thank you very much, Iñaki, for this interesting presentation. What we can take from your presentation as a minimum is that we shall rely on GPS L1 until the end of this decade. And also I find very interesting your recommendation about not using of GNSS as a sole source of timestamping for communication and surveillance system. And I guess it was one of the lessons learned from the event that happened to GPS some years ago. So thank you very much for this presentation. Aviation is in the process of transition from ground-based to satellite-based navigation for all phases of flight. After successful implementation of basic RNAV in en route airspace in 1998, there was a phase of scattered and slow implementation of PBN in terminal and approach operations. Nevertheless, PBN implementing rule has established an ambitious plan to complete the transition to PBN by 2030, with 2 interim targets in 2020 and 2024. Although many states struggle to timely comply with PBN implementing rule requirements, there are also some advanced implementers. Thinking about an example of real transition that include both rationalization and deployment elements, the first name coming to my mind was Benoit Droturier from the SNA, and I'm happy to welcome him among panelists of this event. Benoit graduated as an aeronautical telecommunication system engineer from INAC and obtained a PhD in 1995. He also qualified as an instrument flight rule pilot in 1993. He is now acting as the program manager for CNS Satellite Navigation System implementation within DSNA. He is involved in ICAO and international standardization activities as the chairperson of the navigation system panel and French representative to the performance-based navigation study group. Benoit, the floor is yours.
Thank you, Ivan. I guess you can see the presentation probably.
Yes, we can.
So I will, yes, introduce this presentation. I was asked to discuss why we have and what were the motivation behind the rationalization of ILS Cat I in France and relationship with the PBN regulation. So basically, this was something which was launched by DSNA management in the 2010s. Just before that EGNOS was designed as an operation or finalized as an certified as an operational system. We thought that the capability of EGNOS would be very helpful for us to complete and replace some ILS, in particular those ILS on the small airfields that we were buying, installing, and maintaining, which was quite costly at the time. In particular, maybe you're not aware, but France is, I think, is a European ASP, and DSNA is European ASP, which is involves the biggest number of airports and runway with IFR capability in Europe. In the EGNOS area, we have 69 airports that we have managing directly as DSNA, and there are also 60 other AFIS, smaller airports. But at the time when we designed the strategy, DSNA was providing the ILS service as a state entity for free for these airports. And so this is also something we wanted to a little bit get rid of, because this was quite quite incumbent in terms of money spent each year. So this is basically why we launched initially this strategic evolution. Then the PBN IR came in 2018, and this AR also requested the implementation of minimum operating networks at European level. So what we had done for ILS was indeed more or less terminated at the time when the IR arrived, but it was fully consistent with the regulation. So this was good. And what we did is basically that we launched a new area of works to support the PBN IR toward the VOR rationalization and NDB elimination. I will show you what we did. Just one word, what was very important for us before going to more rationalization was to build a CONOPS, and the CONOPS that we have built in France is a CONOPS to support operations if we have a total loss of GPS and EGNOS over France. So this is we took some time to draft and design this CONOPS with in particular our operational teams. It was quite an important step for us before designing the minimum operating networks. This slide just shows the type of and the localization of airspaces where we are invest the PBN activities. So you see on a worldwide basis, it's more than 160 IFR airports and more than 300 IFR runway ends. But of course, the rationalization mostly is mostly conducted over France metropolitan area, because we have this EGNOS coverage. So I think you all know probably that EGNOS is like a giant ILS signal which is falling from the sky. So it's a very interesting system, very interesting technology and opportunity to complete and replace ILS. In particular, the success of this technology is, I guess, because it's free of charge for NSPs and airspace users. You could do the same thing with GBAS, but for GBAS, you need to pay and for installing an ILS on every airport, and this is very costly. So it's much more for us efficient and cheap to do it with EGNOS. And initially, EGNOS was certified with the APV1 signal qualification. Now we are in Cat I certification, since 2015. So it's exactly equivalent to NLS. And for us, it was quite important also to have this capability to be able to, I would say, to design, market, and sell the transition from ILS to EGNOS to the airports and airspace users. So EGNOS landings are providing the best minima from all PBN technology. So you can support high performance Cat I without airport specific infrastructure. So it was just perfect for us to remove those ILS on the smaller airfields and propose to replace them with with EGNOS LPV landings. And this is basically what we did, as I explained in the 2010s. Now this is terminated. From an airspace user perspective, also, we were quite happy to see that different airlines or aircraft manufacturers tested and flew this EGNOS Cat I procedures when they were first published in Paris Charles de Gaulle in 2015, and we had a lot of very positive appreciations in terms of safety and even with respect to ALS. And what we have learned is that from some airline now, when they have the possibility to fly an ILS or an EGNOS approach, they prefer to fly an EGNOS approach because you also reduce the likelihood of some defaults of ILS like false glide axis or potentially perturbation of the signal by another aircraft or multipass things. So in terms of the ILS Cat I minimum operating network, this is what it looks like. So, sorry. So before we implemented the MON, on the left you can see the airport which had at least one Cat I ILS, and then after airports with at least one Cat I ILS, obviously this is much reduced. Of course, the other airports have not disappeared, but the ILS approaches have been replaced by PBN approach with LPV minima. So where are we now in terms of this minimum operating network? So for ILS, now we have a MON of 38 airports. Those are the 69 that we are maintaining. Thanks to EGNOS, we have reduced the number of ILS from about 100 to 50. So it's we have divided by 2 the number of ILS Cat I in France, indeed. Of course, we maintain the ILS Cat III network because it's not part of the regulation and we have no means to replace them at the moment. GBAS could be a solution in the longer term, but for the moment it's a bit too early to go to that direction to replace ILS Cat III. In terms of money, the ILS MON has generated, let's say, about 5 million euros annual economy for us. So in itself, it doesn't mean much, but when you compare it to the DSNN navigation budget, the yearly navigation budget, this is about 30% of the budget, this reduction of cost. So that was quite interesting in terms of infrastructure rationalization economy. So now we are fully in the VOR MON implementation. So we have designed this MON, as I explained before, in compliance with the CONOPS, which is a total loss of GPS. So we are going from 84 VOR to 51 in 2030, but most of the VOR rationalization will take place during this period, 2022-2024. In particular, we have a lot of pressure also from the French government because VOR are also limiting the deployment of windmills because there are some perturbation from the windmill. So when we have a VOR somewhere, it limits a lot the windmill implementation. And for this reason, also we had a lot of pressure from the government to reduce the VOR network. So here also we will make some economies. For NDB, so our plan is to eliminate most of the NDBs. We have about 100 NDB at the moment. So this will be the next step after the VOR rationalization. And for DME, we maintain the network, and even we are possibly going to increase it a little bit because DME is the main backup for PBN en route navigation and terminal navigation in case of GNSS loss. So in our CONOPS, it's quite an important capability to have this AirNav5 and AirNav1 being supported by DME to be able to land aircraft and restore some traffic if someday we have a big GNSS loss over France. So I guess this is it. Thank you for your attention. And I give back the floor to you, Ivan. Thank you.
Thank you, Benoit. Just to add that in 2024 it is mandated to have SBAS or LPV capability at every runway, also for precision runway, which means that from the perspective of CNS Resilience, there will be full backup to all ILS Cat I with SBAS at any runway. So that's also important, and also it will facilitate further transition towards full PBN operation. Of course, we are still suffering equipage rate, which is relatively low, especially in commercial transport segment operation, because PBN mandates implementation of procedures, but it is not mandated to have airborne equipment. So we believe that it will come once we have these services available. A few weeks ago, I had opportunity to see a presentation from DFS about development of their navigation minimum operation network on grounds of their existing VOR DME network. I determined that it perfectly fits to the CNS Resilience session of this Safety Week, and I asked Ralph Birch from DFS to help us with this. He suggested that Thomas Kleinman, head of terrestrial navigation at DFS, knows everything about the project. Thomas worked for DFS since 1998 as a head of terrestrial navigation since 2000. He is responsible for lifecycle management of ILS, VOR, DME, TACAN, and NDB navigation facilities and the associated remote system. He is also counterpart to the flight procedure designer in all questions of conventional terrestrial navigations. Thomas, please, the floor is yours. Thomas, we couldn't hear you. You are still muted.
Thomas, are you able to unmute? The screen looked good, which is just the muting that's there. Oh, now it's changed.
Good morning, everybody. It's now okay?
Yes, perfect.
Yeah, just we see the presentation, but just in the preview, if you can do the slide, that'd be great.
It's okay now?
That's it. Perfect. Thank you.
Okay. Good morning, everybody. From my side, from DFS, Thomas Kleinman. I have the pleasure to present you the transition phase plannings from VOR DME conventional system to DME RNAV, and especially the resilient for the resilience case, the MON, especially for VOR. Unfortunately, Ralph Birch cannot attend, so I have the pleasure to do it. And I hope I can give you a small illustration of our planning. First of all, the ICAO recommendation, you know, it's to come down with VOR infrastructure to around 50%. This is expected from our planning. We will convert into a VOR MON around 2/3 of the actual infrastructure. Maybe there is a possibility to go down to 50% as expected by ICAO. And this is done as follows. We concentrate on the aerodrome side. We have the advantage in Germany that we can provide service for our route systems if we concentrate on the TMAs on the aerodromes, because we have a high density of aerodromes in Germany. And our plannings are to have one VOR system per TMA. and around 5 to 6 VORs in the en route phase. It's a very small number. So we can achieve a VOR MON as is illustrated here at the end of this decade. It's around 40, maybe it's will be around 30 or even 25, which is around 50%. I cannot tell you the exact numbers now because we do not have a fully mature transition plan now. It's a planning which is has to be calculated for each TMA subsequently in this decade, and therefore there are some options which have to be proven in the near future. But I think we are on a good way to achieve the goal to come to 60 or 50% for the VOR infrastructure. We implement ANAF procedures subsequently within this decade, ANAF 1, SIDs and STARS. And these ANAF procedures will concentrate on GNSS, of course, and DME infrastructure. And as you may know, it would be the highest level of flexibility would be to have RNP procedures, but the RNP procedure require GPS only. We do not we cannot revert within RNP procedures from GPS to DME. Therefore, we are planning ANAF 1 procedures which allow a reversion to DME. And that's the main planning for the introduction of PBN, and the MON VOR is still maintained in the way I described it, one VOR per TMA, which will provide per TMA NPA procedures as well as initial approach fix and at least per runway end one SID, and maybe if it's necessary, we have also per runway end one standard arrival route, relying on VOR DME as in conventional way as a contingency for a contingency case. This is not a full backup. This VOR MON, it's a fallback because you cannot achieve the high level of capacity in case of fallout of GNSS or DME. Therefore, the VOR MON can only achieve possibility to have a fallback to support safe landing, maybe on an alternate airport, and to guarantee a reduced operation in case of GNSS failures or DME. Our main problem is not to have a day without GPS, but to have a day without ANAF. Let's explain this. As I explained already, the ANAF reversion to DME is more or less no problem for a multi-sensor FMS system, but we have in Germany, especially in Leipzig, remarkable amount of aircraft, around up to 20%, which are only multi-DME capable and can only support DME ANAF procedures. That's our main problem. It's not the failure of GNSS in this case, but also the failure of DME. But it's that's more the DME infrastructure is very robust on that, but we have to provide it. And therefore, we are planning increase of the DME infrastructure to have a full coverage, especially in the TMA. And, therefore, we will have here an increase of around 20 to 30% of TME infrastructure, and by the reduction of 1 VOR per TMA, we'll achieve this 50 to 60% on the VOR case. To support the energy transition, especially the wind energy evolution, we concentrate on Doppler VOR. We have now a replacement program in Germany in this decade, which will achieve a full replacement of our remaining VOR installations by new systems. And in this program, we will convert our 7 conventional VOR into Doppler VOR, or in the case of decommissioning of a VOR location, we will have on this location a DME only to support the DME RNAV procedures. In case of ILS, we are not so as mature in our planning as Benoit already presented. In case we do not have detailed plannings to decommission Cat I ILS systems. For the time being, we are thinking about it, especially the contingency case, if will remain at specific airports with Cat I ILS systems in case of contingency. But this is not fully calculated at DFS side as compared to DSNA. Okay. The renewable program has an amount of around 14 VOR plus some options, which is due to the that we do not have a fully calculated transition plan, and we will convert some lack of infrastructure here. We will decommission around 20 VORs and convert them to standalone DME locations. And as I already said, our default fallback for GNSS is ANAV 1, is DME IRU or IRU, which allows different fallback solution. For the en route case, we will have VOR DME ANAV 5 infrastructure, which will rely more or less on the VORs located on the individual airports. As I said, it's around 1 VOR per airport. The MON approach in Germany assumes that the VOR DME sensor will be a backup of the backup, and the main resilience backup system will be DME, and therefore we concentrate on this infrastructure. The VOR MON will not be a full contingency backup system for ANAV 1. It will be operational network which allows only conventional navigation and support of the ANAV 5 for the en route case, and therefore we expect a case of a complete outage also for DME that we will have reduced operation in Germany. That is already coordinated with our Department of Traffic, this approach, and therefore it's, I want to give you the message that our VOR MAN is not a full backup. It's only a fallback for contingency. Okay. Here, the last slide. See here the infrastructure in Germany, where we can see in green the locations where we have now a VOR DME and will convert to a DME only. And I think we are here in line with the expectations of ICAO. We have here also you can see the existing DME infrastructure also. Here in yellow, we have the optional cases which have to be calculated in this decade because of our subsequent planning of the transition through this decade, as I already said. Okay, that's all from DFS side. I hope I could explain our approach to you, and thank you for your attention.
Thank you very much, Thomas. What I see as interesting is that you take care also of aircraft that are only DME capable. So that's actually because it somehow it is done not everywhere, I would say. So that's thank you for this presentation. CNS Resilience is not only a matter of navigation, but also communication and surveillance. What concerns communication, Europe has established a data link service as a complement to the established VHF voice communication. We learned that the VHF data link is not capable to accommodate all demands of data link communications, and the final objective is to have available a workable multi-link solution. The first step in this direction is the IRIS project. One of the most advanced implementers and users of data link service in Europe is MUAC. Thierry Saleh is going to share the MUAC experience with data link. Thierry is a master in engineering from University of Liège. He became team leader of data communication system at MUAC in 2013, always focusing on data link technical applications. He was steering the technical development of ACN baseline 2 in MUAC in 2019, and he is involved in all data link activities for MUAC, of course, including the IRIS project. Thierry, the floor is yours.
Yeah, thank you, Ivan. Can you see the slides?
Not yet.
Not yet.
It's normally shared. You cannot see it? So I'll try. Okay, sorry, like that.
No, it's coming. There it is.
Excellent.
Yeah, perfect.
Okay, good. Forgot to confirm the share. Thank you for the introduction. So maybe because the public is wide here today, so MUAC is the NSP in charge of upper airspace above Benelux and northwest of Germany. And indeed, we have been active in data link for many years already. So data link, it's initially CPDLC, which is, as everybody knows, used for, everybody may know, it's used for pilot to controller communication, exchanging text messages. And nowadays, with the second version of ATN baseline 2, so the ATN baseline 2, we started the deployment of ADSC, which is not the follow-up of ADSB, but it's really a data link application. Data link is currently, or was up to now, mainly relying on VHF, so VDN mode 2 in particular. And here I'm showing very quickly or very high level view on how we are providing the service for data link in our airspace. So we are, let's say the gray box is represent our technical infrastructure, and we are connected to two providers. The cloud in the middle represent, in this case, SITA, which was deployed VDN mode 2 infrastructure in our to cover our airspace, and we are also connected to AirLink at the bottom. So those two providers have deployed the VDN mode 2 stations, which provide the ATN service in addition to the AOC service. So far we have been using VDN mode 2 for supporting CPDLC and ADSC, but we know that IRIS, which is the common project between was deployed by developed by EASA and will be put in operation by Inmarsat. Will provide SATCOM based communication service for ATN aircraft. So I'm just trying to show how we will be connected to the IRIS service in the short term. We expect that Inmarsat, and which is the case now for the initial flight or the validation, Inmarsat is connected to CETA, and from our ground perspective, our system is connected directly to CETA, and CETA relays the traffic to Inmarsat. So in the coming year, the IRIS service should be there, it should be deployed to provide the SATCOM service for VDL Mode 2. Okay. So for us, IRIS is part of the multilink concept. So where aircraft will be able to use different technologies for communication with ground. So I quickly showed what is expected. Okay, Aeromax is only at some airports, so it's maybe not so much deployed, but VDL Mode 2, LDAX is also in the preparation phase. SATCOM initially with IRIS, maybe with Iridium later, but IRIS will be the first one. Okay, just maybe for safety, what are the CPDLC benefits as maybe a reminder? Okay, I show you quickly, but I will go in all the details. We decrease the number of readback errors or communication errors. We have some redundancy in terms of I'm lost. My colleague told me I'm lost. Can you hear me?
Yeah, no, we're good.
Perfectly.
Okay. Only my colleague could not hear me. Sorry. In terms of communication redundancy, we have CPDLC as alternate to voice or as a second means of communication. For sure, capacity and increase in capacity, cost efficiency, automation. So I will go a bit more in the details. For what is the benefit of CPDLC for safety, and it is very important because IRIS is going to participate and provide more capacity to support the CPDLC service, but we have less misunderstanding, so less time spent on the VHF to repeat clearances. We avoid as well double transmission when several pilots or controller pilots try to communicate on the VHF at the same time, on the radio at the same time. We have also less SATCOM incident. We have also, in terms of redundancy, the fact that we have CPDLC allows as well to be less sensitive to the VHF interference. Due to weather, to other kind of interferences, loss of connectivity due to aircraft being too far from the VHF station, stuck push to talk button, or other kind of problems that may exist on in the daily life, let's say, of the controllers. Other benefit of CPDLC for sure, it's capacity gains. So we know that in MUAC, the main constraint for the moment in terms of capacity is mainly the time on the radio, on the frequency. So having CPDLC in addition to that will allow controller to focus more on urgent clearance by the radio and on less urgent clearances via CPDLC. So like frequency change, change of SSR code, and so on. Also, the frequency change is usually one message that can lead to misinterpretation due to the 6 digits. So it's much easier via text. And freeing capacity will improve the profiles, the flight profiles, and leads as well to CO2 reductions. Related to that, we have also expected capacity gains, 11% based on simulation, when there is 75% equipage. It's not formalized so far in our TMVs, but we know that it is the case, and we know that the capacity of our ops room is higher when data link is there, and if we would have to stop data link, we would have restriction directly in place. The last two benefit of data link would be support to automation. We know that at MUAC we are working on starting to not automate ATC, but provide some facilities to the controller to automate some clearances. So they would be prepared, let's say, in the background, and they would have just to uplink them by clicking on the HMI. And then last but not least, data link. Just a second. So data link is helping to support the deployment of CP1, which is APP and ADSC. That's really one of the expected benefits in the coming years, is to have to enable I4D operation. So let's say get optimization of the flight profiles. When we talk about top of climb, top of descent for the aircraft, so providing the pilot the best or the optimal top of climb or top of descent, which is allowed through the use of ADSC data. I don't have time to explain much more about ADSC because it would require another hour, but I think you can look or you can ask feedback afterwards. Now, just to focus a bit on IRIS SATCOM, what will be the benefit or expected benefit in addition to VDL Mode 2? So if I start on the left, we indeed have an increase of technical reliability. Okay, the technology is more recent, it's more mature. We have only one SATCOM constellation, would be managed instead of several VHF ground stations supporting VDL Mode 2. Expected to have better performance based on flight trials. We have much more capacity in terms of bandwidth, which is welcome for CPDLC, but mainly for ADSC to support the EPP downlink. Okay, the IRIS service will be certified by an European service provider, which is not the case for the moment for VDL Mode 2. So certify would mean procedure, also for change management, for incident investigation, for service availability, monitoring, and so on. There is new avionics, which expect to be better. And the last point, I will come back to the next slide. And in terms of infrastructure, we have less interferences. For example, we have seen so far regularly, but we are not constantly monitoring interference on the frequency allocated to the VDL Mode 2. So we have 5 frequency allocated to VDL Mode 2, and they are in the range of the voice frequency. Even if they are reserved, it happens regularly that some aircraft are misusing that frequency by mistake or due to error somewhere they tune the wrong frequency. So it's impacting a lot the VDL Mode 2 service. There is no hopping from VGS to VGS. For sure, there is security features, so the use of authentication and restricted access thanks to PKI, public infrastructure. It's also not possible to tap and to listen to message. And for sure, IRIS is a backup of VDL Mode 2 in case of overload or in case of the 18 airground router failure from one of the provider SITA AirLink, which unfortunately happens from time to time. And then for me, I wanted as well to highlight some of the challenges of SATCOM because it's still in the making. It's not yet fully operational. It's deployed, but not in operation. We want to make sure the challenges or expected challenges is whether the performance is really going to be better when we have a large scale deployment. The capacity, how is it going to be made available to all the aircraft, to all the aircraft flying around. The larger bandwidth, okay, but will it be enough to enable all EPP downlink as well? We hope no new technical problems will be found. And in terms of service, okay, the service still needs to be deployed. We have still a few question marks about the cost, which is a big driver for the airline for sure, airline users and the NSP as well. And there is a political discussion as well to get the deployment in all Europe. But the good news is that we will have 10 more flight trials coming on Airbus A320neos, mainly on EasyJet, which are ATN B1 and B2 equipped. And we want to get all NSP involved in those flight trials. Okay, I think I covered in a very, very short 10 minutes time. I covered all the topics. If you may have questions, please raise them to the chat. Thank you for your time.
Thank you, Thierry, for this very interesting presentation. I would like just to highlight that indeed this IRIS can act as a backup to VDL mode 2, but also vice versa. As a setup for IRIS flight trial, is that VDL will act as a backup to IRIS solution. What is needed by aircrew for navigation and communication? Typically, aircraft operator install airborne CNS equipment in two cases: when it brings some operational benefit or when it is mandated by regulations. Of course, mandate should come only when it is necessary and in the right time to avoid situation that aircraft is forced to carry equipment worthy only of the price of metal from which it is made. Steven van Hourigen is flight instructor at the Authorized Training Organization, compliance and safety manager for an aircraft operator, training organization, flight training devices operator, senior inspector airspace for Dutch authorities. He is 737 and 787 rated, currently flying the 737. Next to this, Steven works as independent aviation external expert for EASA, and he has his own aviation consultancy company. Steven, the floor is yours.
Thank you, Ivan, and good morning to everybody. And thank you for inviting me for this presentation and webinar. It was really interesting to listen to the other panelists. Learned a lot. And today, the question for me was to talk about PBN and CNS rationalization. I got a nice picture of a colleague of mine in low visibility conditions, as you can see. It's actually at the Schiphol Airport. And next slide, please, John. And I have to admit, as a non-native speaker, I was wondering what rationalization actually means. As a pilot, I always want to know how it works and how we go with it. So I actually looked it up, and for me, what I found out is that it is a change or reorganization in order to increase operating efficiency. And that's what we actually saw already in the other presentations, that we want to lower costs, improve routing, and we want to have more traffic in the air, because it's already busy enough. And to do that, we use PBN and GNSS. Next slide, please. And I wrote an article about PBN operation from the perspective of a pilot. And if I look at PBN from that perspective, there are four aspects we consider. And that's the airspace, the operator, the aircraft, and the pilot. The airspace requires PBN, of course, or RMP. The operator needs to have an approval or PBN approval or an RMP-AR approval. The aircraft needs to be certified and capable to use it, and the pilot, of course, needs to be endorsed and trained. I want to discuss all four aspects from the view of a pilot. And if you look at the first aspect, airspace, it's already discussed. We need to transition to full PBN at 2030. So what I see is in the air that en route, we see RMP required, RMP2, RMP4, RNAV5. And the conventional approaches are disappearing and are being replaced by RMP and LPV approaches. The LPV approach is Cat I, of course, as already explained, and there's not really an active alternate. It's already there, but not installed yet for Cat 2 and 3. But the thing is, how many times do we use Cat 2 or 3 approach? That's not really that often. In my experience, I have used it only once. And of course, I want to mention the CPDLC. I see the change. For example, if I fly from Amsterdam towards the southern part of Europe, in the beginning we log on, but there's still, I see there's a transition period because we log on and there's a combination of voice and CPDLC messages. So the CPDLC says contact the next frequency and we accept, but then via voice we get the descent clearance or the climb clearance. So it's not fully integrated yet, so there's still some challenge, I think. to gain from the benefit from CPDLC because I really like it. And if I look at the aircraft themselves for CPDLC, thank you. The aircraft I'm flying currently, the CPDLC I use in the FMC. So I'm switching between two systems. And we have two FMCs on board, but we have a pilot flying and a pilot monitoring. So it may be well that the aircraft currently in use are not fully equipped to easily use CPDLC. So there's a challenge as well. In a modern aircraft, I flew the 787 as well. That's fully integrated and easy to use and not interfering with other systems. All right, the next slide. Then talking about the FMC, you see it in the back in a shaded picture. Basically, as a pilot, I follow the lines, and the input is based on either GPS, VOR, IRS, DME updates. And as you can see in the back, in this aircraft, the DME updating was off. So if I go back to the discussion where we're going to install more DME updates, for the operator, we need to consider what our standard setting is in the FMC. That's a highlight I wanted to note, because if it's not a standard setting, then we'll may have problems in the future. GPS, of course, always the standard on, and crew training, if we do an RMP-AR approach, we select VOR updates off, for example. That's an extra procedure. So nowadays in the operators, it feels more like that RMP is not yet the standard. During en route structure it is, but during approaches, not really. And it feels like an add-on. So if we fly an RMP or RMP-AR approach, there's an extra checklist. So it's not yet the standard. So that, again, emphasize the fact that we are in transition period. Next slide, please. The aircraft, talked a bit about it already. The aircraft needs to be certified. What I see today is that they are approved for RMP1, RMP-AR, and but you may need to invest to get LPV approved or advanced RMP, or maybe even the newer technologies. And basically, the older the aircraft, the less equipped. If I look at the previous company I worked for, they did not even have the correct GPS yet because the aircraft was just old. And they're installing it, or already have installed it. I don't know yet because I left the company a couple of years ago. But you can see the older the aircraft, the less equipped. So that needs to be taken into account with the backup systems and the transition to full PBN. And then last to the pilot. The pilot, as far as I have seen and know, most pilots have a PBN endorsement on their license. It's required now for the instrument rating. And our focus is already on looking at the required navigation performance and the actual navigation performance of the aircraft. I will go into that in the next slides. Instead of following radials and DME distances. But the thing is, if we gonna decommission the ADFs and some VORs, that may have an influence on the flight training schools. So if I look at schools, they still require that student pilots need to train on VOR interceptions, ADF interceptions, or VOR or ADF approaches. For example, in the Netherlands, there's only one airport that still has an NDB approach, and there's the VORs are limited. So what they actually did in the simulator, they froze the navigation database update to keep training those VOR and ADF approaches and VOR ADF interceptions. So I want to point out, if we want to require flight schools to keep training VOR or ADF approach, where I think that ADF may well be decommissioned because it's getting old, like the floppy disk we used in the computer, whoever can remember it, we now use the cloud instead of the USB sticks already. So there's a time to decommission old stuff. So, but VOR interceptions will continue, I guess. So that's why the minimum operating network, I liked what Thomas said, that the VORs will be at the airports, because that's more convenient for flight schools. They can fly VOR approaches, but also do VOR interceptions at higher altitude. That's one thing I want to mention for the minimum operating network. To end with, I have an example. I actually checked what happens if we switch off GPS updating. And if we go to the next slide, John. As you can see on the primary flight display here, on the lower part, you see two white bars. And those white bars are normally short ones, all the way to the edges. And what we did actually during en route, we can manually select a required navigation performance of 0.3 instead of the 2.0 we required actually. So we were still safe, of course. That's primarily the idea. But we wanted to check how long it would take for us before we were out of limits. And we put in 0.3, and this was after approximately 8 minutes. If you go to the next slide, you will see the warning system that says, hey, you're out of limits, because at this time, 15 minutes later, without GPS updating and without DME updating, I have to say, we were at the limit. So if we go to the next slide, you can see in the navigation display, on the bottom part, where the aircraft symbol is, the required navigation performance manually selected was 0.3, and the actual navigation performance was 0.31. Normally it's 0.01 or 0.02. So I was wondering what happened if we switch off GPS updating. It's a slow decrease of the actual navigation performance, but it will continue. And of course, with DME updating, we will stay within limits. But it's good to know what you actually see in the cockpit when it happens, when GPS fails or is jammed or whatever. And of course, in the pre-flight checks, we look at where the jamming areas are, so we know what's coming. That's my viewpoint from the pilot's aspect. Thank you for listening. I hope I kept it short, so there's room for some questions.
Thank you, Steven, for your presentation. Also, thank you for this experiment with navigation performance after the reaction for failure of GPS. That was really interesting. I found also interesting to see despite your aircraft is capable of DME navigation, it is not by default granted that in the case of failure of GPS, the aircraft will automatically switch to DME navigation, as it was, let's say, off in your setup. So it was really interesting. So thank you for your presentation. Now I think that we are a bit later than initially expected, but I can see two questions. And maybe it is the right time to reply to them. The first question is, what are European Commission's plans for interoperability with non-EU US GNSS system for aviation, like Beidou or GLONASS? And I guess it is a question to Iñaki.
Yes, so indeed, the standards will allow, the multi-constellation, multi-frequency standards will allow the possibility to include particular GNSS for the particular region. In Europe, we are going to qualify our DFMC SBAS for GPS and Galileo, but the standard itself will allow Beidou and GLONASS. So this is going to be allowed by standards on the SBAS side. And the GBAS side, I think they are going to follow the same approach. For the DFMC GBAS, there will be a standard allowing the 4 constellations. So this is going to be the case. So in principle, the equipment installed in one aircraft will be able to use GPS and Galileo in the regions where that will be the main solutions, or if they are over Russia and China, they will use their local systems. This is possible.
Thank you, Iñaki. And also, as you mentioned, that future EGNOS will support GPS and Galileo, but not initially not Beidou and GLONASS. Then next question is to Thierry, and it is about capacity gain of 11%, and the question is whether do you have any projected cost efficiency gain with respect to data?
No, we don't have any cost like I would not be able to tell that. What we want to do with data link is for sure provide the best service. So at the end, our service becomes more efficient for, let's say, for all the airline community, and we want to have we are able to have more aircraft, so for the same, let's say, cost base. So for an individual airlines, it's difficult, but yeah, I mean, difficult to quantify. But for sure, there is a discussion indeed, because there is a mandate for ATNB1 above for flight level 285. So, but it's more a question for European Commission to say how is the mandate applied in practically, on question to NM as well. But maybe it's a long debate for today. Aircraft should only aircraft with the data link equipment should be allowed above flight level 285, which is not the case for the moment. But if we have capacity problem, it will be discussed.
Thank you, Thierry. We started with GNSS Resilience and our strong reliance on GPS L1. What would happen if for any reason the GPS L1 is lost? Iñaki, will the future GNSS DFMC receiver work without GPS? Or in general, what are the fallback modes of the considered in the drafted standards?
So the DFMC SBAS standards are being worked out, as I mentioned before, at the moment. And of course, the default mode will be DFMC, so 2 constellations, 2 frequencies. If we lose any of the constellations, we can fall back to just 1 single constellation, be it GPS or Galileo. This will be allowed by the standard. However, in terms of frequencies, if we lose the L5 constellation, we can fall back to L1, but the standards do not allow to lose L1 frequency and fall back to L5. This was discussed and analyzed in the past, a couple of years ago, and it was decided that due to the complexity and due to the probability of just losing 1 frequency and not the 2, the only fallback mode in terms of frequency for SBAS was losing L5. Still, you could go back to the legacy L1. These other augmentation technologies like HRAIM will allow still having navigation capabilities, even if we lose the current L1 signal. Okay, so HRAIM will target horizontally RMP.1 when we have GPS and Galileo L1, L5, but we will go to a kind of RMP.3 if we lose, for instance, the L1 capability. So there will be means to navigate if we lose either constellation, either frequencies, but still with degraded performance.
Thank you, Iñaki. Benoit, you presented the IRIS Cat I network as a MON for the case of loss of LPV. The question is what is needed to further progress with the ILS Cat I decommissioning, whether we need to wait for DFMC or do you consider some, let's say, earlier mitigation which would address only GPS L1 to, let's say, to reduce further the network of ILS Cat I station?
Yes, thank you, Ivan. Yes, for the moment, we consider that the reduced networks that we have implemented and that I have shown on the slides will be the one which will be applicable in 2030. Now, if we wanted to reduce more than that, I think we will need more conditions on the availability of SBAS. For the moment, EGNOS is 99% availability designed. Next generation is still at 99% for 2030. For us, it's not enough already, but so we are discussing with European Commission and USPA to increase this range of availability for EGNOS. We are also asking that in the future, EGNOS is capable to be working only with Galileo. For example, if we lose GPS, we want the system to be capable to work only with Galileo, and this is for European independency. At the moment, this capability was part of the regulation for the new version, but it's not been retained in the versions under design. So we expect that the type of possibility or function will be there in the future. So In fact, what we need, yes, would be a guarantee of a next level of availability for the system. This would be required to go over, because for the moment we retain all this ILS because we want to be able to land safely aircraft if we lose the system under any condition.
Thank you, Benoit. We hear a recommendation that communication and surveillance system should not rely only on GNSS time stamping. Thierry, the question to you: is your communication system robust against GPS failures? For example, in the case of loss of time synchronization, as it happened in January 2016, that was known as the UTC offset anomaly.
Yeah, okay. There are several aspects to that question. For sure, our system, ground system as NSP, is relying on GPS as a time source, but we have local time servers providing NTP time service, which is able to survive 6 months without synchronization. I think there is only once a month or something a synchronization to the GPS. This system also has anti-spoofing, anti-jamming features as well, so it's quite advanced, quite robust. But for sure, we also rely on external providers for communication, like let's say KPN or Dutch Telecom or German Telecom and so on. So yeah, for what we can control, for sure, we are self-supporting. But for external service provider, okay, that could be a problem. But usually at application level, let's say, if I would focus on data link in this case, we have some strict time verifications or messages like that are exchanged with CPDLC have to be timestamped within a certain limit. So it's also on the other side, the avionics side. The GPS synchronization is important, otherwise message would be discarded. Yeah.
That's a really interesting observation. Thank you.
Yeah.
In fact, when I was looking for some outcome of some trials, what would happen in the case of failure of GPS or loss of GPS in wide area, I realized that there were some studies some time ago, maybe 1990s or early in 2000, I think until 2005, there was a study of FAA, which was very limited to en route airspace. But now the use of GPS or GNSS in general is much more advanced. My impression is that we would really need a kind of, let's say, repetition of such experimentation. What would be the real consequences of loss of GNSS in wide area, especially now in these days when we are, let's say, in front of situation when we can experience jamming from let's say in wide scale, and I think that we really need to better know what could happen in the case of GNSS.
Yeah. Yeah, as just a last point, I also discussed with one colleague with surveillance specialist, Artas, responsible for Artas in our company. And he told me that all the track or all the radar plots that are coming from the radars on ground are timestamped as well. And if there is a difference like of more than 2 seconds, the plots would be discarded by Artas. Okay, we have multiple coverage and so on, so we should survive it. But indeed, there is a dependency on time synchronization.
Thank you. Regarding the minimum operational network, Thomas, question to you: is your DME network designed to support also PBN operation in terminal airspace? You mentioned that you considered also to extend the network also with the densification of DME. Do you intend to cover all DME or some of them? And what is the determining altitude for that? How did you take into account such consideration of coverage of DME, this terrestrial system?
Yeah, it's the DME coverage is an essential characteristic, and we focus on an assessment, DME coverage assessments, and for the time being, we intend to use every location which is still now part of our navigation infrastructure to install or remain the standalone DMEs to have a full and backup coverage of DME. for that. That's a big challenge for our assessment. And, therefore, we expect an increase of DME infrastructure by 20 to 30%. Yeah.
Thank you, Thomas. Steven, you mentioned in your presentation that PBN there might be some issues with training for commercial procedure. In fact, PBN implementing rules counts on availability of some commercial procedure in the case of issue with GNSS. This means that aircrew shall be qualified for them. Do you think that it is, let's say, reasonable to anticipate that these training and facilities will be available to achieve qualification of crew to fly commercial procedure from long-term perspective?
For the PBN implementation, I think we still need a minimum operating network to rely on to fallback for VORs or something like that. And if we continue to implement as the plan is, then we need more RMP approaches to actually train it. In the simulator is one thing, but in an actual aircraft operation is another thing. So they will need to continue to implement RMP procedures, yes. And for the training procedures are already written, so there's not really a new addition to that. So we can continue on that one.
Thank you, Steven. I think that we run out of time. I don't know whether we are allowed to continue with a few more minutes.
Yeah, I mean, we've got a couple of minutes if you've got some other questions or whichever.
Maybe if you allow me one question to Iñaki, and you presented a timeline for development of the DFMC SARPs, MOPs, and also some anticipation of development of receiver. But the question is, what do you think will motivate aircraft operators to buy this new receiver in the future? What will be the kind of driver for that?
For DFMC receivers, well, first, that the service will be better than the one offered today. So not only in terms of performance will be better. We will deliver, for instance, in terms of SBAS, a higher area. You know that with 2 frequencies, we remove the IONO contribution. So in the border of Europe, where SBAS services are not always available 99% of the time, they will be no longer a problem. And then the second benefit is what we mentioned before. There will be redundancy in case we lose one constellation, or maybe if you lose one frequency, you can still navigate with HRM with the other frequency. So the performance will be better, and I think we will tend to go to multi-constellation, multi-frequency, as ICAO has recognized.
Thank you, Iñaki. Bernard, PBN implementing rule mandates availability of LPV procedures, but not the LPV-capable avionics. We see the installation of LPV avionics move slowly, to be more precise, extremely slowly, in particular in the segment of commercial transport aircraft. What could be done better to meet the 2030 target without impairing capability of aircraft to fly 3D Type B approaches?
Yes, obviously it's an important point. It's not as slow as it was before. When you look at the trend now, you have many airlines which are interested in the LPV capability. For example, in France, I discussed a lot with Air France. Air France is now was not really convinced by SBAS 10 years ago, but now they want SBAS on all their aircraft. They want to retrofit because they understand the potential of this technology. So I think that things are much better now than they were 10 years ago. In particular, what airlines are looking for is what is the worldwide surface covered by SBAS, and also in this direction there are a lot of progress. There are projects for SBAS in most regions of the world. For example, there is a big project now which is going to start in Africa, and this is one of the reasons why also Air France is pushing, because in Africa this type of system is even more useful than it is in Europe. So I guess that we need to continue education, promotion of benefits, and continue developing, supporting the development of SBAS all around the world. This is the area that we need to continue pushing to increase the airborne technology development.
Thank you, Bernard. Thierry, during IRS flight trials, VDL equipment will be installed on board and configured as backup when the SATCOM is lost. In the future, would you be able of CPDLC with aircraft equipped only with SATCOM?
Yes, so as you may know, CPDLC is using the ATN protocol, which is running over either SATCOM or over VDL Mode 2. And on the ground side, actually, we are so far in the current connection we are even not aware about which is the means of communication that is used. So as long as there is an end-to-end ATN channel, let's say, or connection, it works. So it's fully transparent to us. So there is no issue.
Thank you. The last set of questions is about some integrated CNS and common mode failures. Iñaki, GNSS is used virtually everywhere, and we are not at the end of the road. For example, impact of the GPS UTC offset anomaly on surveillance systems surprised many of us. Can we do more to prevent common mode failure of GNSS?
Sorry, was this a question for me? I didn't understand whether you said my name.
The question is what else we can do to prevent common mode failure of GNSS or related to this?
But it's a question for me, isn't it?
Yes, Iñaki.
Okay. Well, we are trying to do our best to prevent that indeed the systems themselves, they fail. And I think we are reducing the probability of that happening. GPS failed in terms of UTC timing in 2016, as you mentioned. Galileo has also had in the previous year some outages. Thankfully, lately we are not having any outage, so it's still on the way to becoming final operational capability. And I believe that the probability will be very low. We are improving the systems, and with the multi-constellation environment, even if the probability is so low and we still have one failure of a system, the other system will not fail because they are independent systems. So I don't think the weaker point of the chain will be that the system themselves will have an outage. I think that it is much weaker that at user level there will be interference, or there will be some kind of event that will prevent locally or regionally the use of GNSS signals. So of course, this is still a risk on the GNSS side and will impact all users, but I think we are working hard to have this very, very low probability of occurrence.
Thank you, Iñaki. Steven, we can see integrated CNS solutions not only on ground, but also in the cockpit. For example, communication management units can handle all communication means. We have extensive use of multi-mode navigation receivers that integrates nav, DME, GBAS. We use widely multifunction displays in cockpit of modern aircraft. So although these features significantly reduce fragmentation in cockpit, do you see some, let's say, additional safety risks to be addressed by design or aircrew training, which might be related to this, let's say, common feature or this integrated equipment?
Yeah, good question. Like I said in my presentation, nowadays the older aircraft will have some kind of system implemented into the cockpit, which normally wasn't designed there. So we need to take into account that there shouldn't be a distraction while flying the aircraft with the new systems. Like I said, if you switch in the FMC from one page to the other and then back to the other again, that's distracting. And for CPDLC as well, what I see is that we get a lot of messages like you may log on, you are logged on, current center is, while we checked in with voice already. So maybe we can work on that to reduce those messages to an effective, how do you say, amount while keeping it safe. And yeah, the more we can get the main system in the view of the pilot, so near the PFD, the ND, that helps as well. So for example, in the 787, there's an accept button, a reject, and a cancel button, and you can see the messages next to your PFD. So as pilot flying, you can easily see what's happening without pulling heads down. That's what I see for the integration for that.
Thank you, Stephen. I think that.
Thank you.
Yeah, we covered lots of topics. I think we've got people ready for the next session now. We've got 20 minutes between now and the next one, so I think we've rounded it up now.
So from my side, thank you very much for all the panelists and also for participants to this session. Now I will give the floor back to John.
Fantastic, thanks. Well, yeah, again, thanks, huge thanks from me for all our panelists, for all of the audience. Yeah, hopefully you found it a useful discussion, and please join us again for other sessions when we do them in the future. Thanks very much. Goodbye.
Thank you. Goodbye.
Thank you. Bye-bye.